Welcome back, everyone, for another deep dive. This time we're headed to Singapore.
Virtually, of course.
Well, yeah,
Not literally.
to explore how they're using these things called open educational resources to teach physics.
Sounds pretty interesting, right?
Yeah, definitely. We found this amazing website called
Oh, yeah, I saw that.
Open Educational Resources/Open Source Physics at Singapore.
It's a mouthful.
Yeah, but it's amazing.
It is.
It's full of all these interactive physics
It
simulations.
has stuff.
I can't wait to dig into it.
What I find so fascinating about all this is that Singapore, a nation with really rigorous STEM education, is like fully embracing
Yeah.
this idea of OER.
Okay, so for those of us who maybe aren't familiar with the term,
Yeah.
what exactly are open educational resources?
So essentially, they're teaching materials that are totally free online.
Anyone can use them.
Exactly. Like, seriously, anyone can use them and adapt them too. And it's honestly a game changer, especially in a world where, access to good education,
Isn't equal everywhere.
yeah, isn't so. Even makes things a lot more fair.
Okay, so tell me more about this website, this Open Educational Resources, Open Source Physics at Singapore.
It's pretty comprehensive.
Yeah, it looks like it covers a lot.
Oh, yeah. They've got stuff for primary school, secondary school, and junior college.
So they're really building that foundation.
From a young age.
Yeah, from the beginning.
Which is really cool to see.
I see they have a ton of simulations.
Yeah, they're really into those.
How effective are those in actually teaching physics?
Oh, they can be incredibly powerful.
Really?
I mean, think about it. Imagine you're trying to learn how a car engine works.
Okay.
Would you rather read about it in a book
Oh, definitely not.
or, actually take it apart?
Get your hands dirty.
Yeah, see how it all fits together.
Sinker.
That's what these simulations let you do.
But for physics concepts,
Exact.
that's amazing.
Yes, it is.
So you're making the abstract.
Totally giving them a way to really see these complex ideas. I know. And they have simulations on a huge variety of topics.
That's
Like,
awesome.
for instance, there's one called Simple Electric Circuit.
Okay.
Helps students understand how electricity flows.
And circuits are.
Oh, they can be tricky.
Yeah.
Especially all those misconceptions people have.
Misconceptions? Like what kind of misconceptions?
Well, you know how a lot of people think of electricity like a one-way street?
From the battery to the light bulb.
Yeah, like that. But it's way more complicated than that.
Oh, I bet.
The flow is influenced by all sorts of things like resistance, arrangement of the components,
So the simulation breaks it all down?
visually.
That's cool.
So you're not just learning the right answer.
Right.
You're challenging those assumptions.
Getting deeper.
Deeper understanding.
That's where the real learning happens.
Couldn't have said it better myself.
Okay, so we've got simulations for electricity. What else is there? I have to ask about this one. Amazing pendulum wave effect.
Oh, I know why that caught your eye.
I mean, the name alone.
It's amazing.
Yeah, it's amazing.
What's even cooler is it combines physics with a little bit of art.
Okay, I'm intrigued.
So picture this.
Okay.
You have all these pendulums
Right?
hanging from a bar. Right.
Yeah.
Each one's just a tiny bit longer than the one next to it.
Okay, I can picture that.
Now imagine them all swinging at the same time.
Wow.
It starts synchronized.
Rag back and forth.
But because of that slight difference in length, each one has a different speed.
So they get all out of whack.
Well, they create these wave patterns.
Oh, wow.
It's like a choreographed dance
So it's like a visual representation of physics.
in action.
Too.
And it shows how even tiny differences
At the beginning.
can lead to these super complex patterns.
That's incredible.
It is.
And those are just two examples.
I know, right?
This website has a ton more.
A whole library.
I'm looking at their popular tag section and I'm seeing things like molecular workbench, the periodic table.
There's even fractions of a whole.
What?
I know, it's crazy.
Physics is everywhere.
It really is.
It's connected to everything.
It's not just this isolated thing.
Right.
It's intertwined with biology, chemistry, math.
It's the foundation.
Truly.
I love that this website shows that.
Helps students see the bigger picture.
Okay, I'm definitely getting the sense that this is like a gold mine.
Totally.
But what makes these resources specifically relevant to Singapore?
Ooh, that's a great question.
I mean, is there something unique about how they're using them there?
This is where we get to the why.
Okay, the why behind the what.
Exactly. Singapore's always emphasized STEM education, right?
Science, technology, engineering, and math.
Yep, all of that.
Yeah, they're big on those fields.
Seen as super crucial for innovation and economic growth.
Yeah, makes sense.
And what's really interesting is how they approach it. They always try to integrate theory with practical application.
So it's not just about memorizing formulas.
It's about understanding how it applies to the real world.
That's what I like to hear.
And that's where these simulations come in.
Yeah, they bridge the gap.
Between theory and practice.
Let them experiment and explore.
Way more than a textbook can.
So it's almost like these OER are tailored.
Oh, yeah, in a way.
To fit Singapore's educational philosophy.
Precisely. They really align with their focus on hands-on learning and problem solving.
And I also read that these simulations are often developed.
Oh, yeah.
In collaboration with local universities and research institutions.
They're on the cutting edge.
So they're not just generic simulations.
No way.
They're incorporating local expertise.
To meet the needs of Singaporean students.
That's awesome.
It is.
Okay, so we've established that this website is this amazing resource.
A treasure trove.
Full of simulations, carefully curated, aligned with Singapore's educational philosophy.
You got it.
But what about the impact? Like, do we know if they actually work?
Oh, there's been some really cool research on that.
Really?
One study found that students who use the simulations regularly showed like a massive improvement.
That's what we like to hear.
Compared to the textbook-only group.
Okay, so there's data to back it up.
Data doesn't lie.
So they're not just effective, they're also
helping
foster a greater interest in STEM.
Which is key.
I mean, you make learning interactive and fun.
Who wouldn't be more interested?
Yeah, exactly.
It's all about sparking that curiosity.
That love of learning.
That's what it's all about.
Okay, so we've covered the philosophy behind OER. We talked about how Singapore is implementing them, but I really want to dive deeper.
Into the simulations.
Yeah, let's start with that simple electric circuit one.
Okay. Let's break it down.
What are some of the key things that students can learn from that?
Well, it basically lets them build their own circuits virtually.
Oh, wow.
They can add batteries, wires, bulbs, resistors, you name it.
It's like a virtual lab.
It is. And they can experiment with changing the arrangement of things.
Like adding more resistors.
It's increasing the voltage of the battery.
And they see how it affects the flow.
In real time.
That's so cool. They're not just absorbing information.
They're engaging with it.
Figuring things out for themselves.
Love that.
It's a process of discovery.
Exactly.
Can you give us an example of how this addresses those misconceptions?
Sure. One big one is thinking the battery is the source of all the electrons.
Right, like it just makes them...
Right. But in reality, the electrons are already in the wires and stuff.
Oh, wow.
The battery just provides the energy to push them around.
So it's more like a pump.
Perfect analogy. And the simulation lets them see it.
See the electrons moving.
Even without the battery.
Whoa.
Right. It helps them get a much deeper understanding.
Of how electricity really works.
You got it.
That's fascinating.
It is, peeling back the layers.
I love it.
Seeing those mechanisms.
Okay, so we've explored the simple electric circuit simulation. Now I'm ready for the amazing pendulum wave effect.
Oh, this is a good one.
We've really built this up.
It's a visual feast.
Okay, what makes it so visually stunning?
And educational at the same time. Yeah. All right, so you have your row of pendulums.
Got it.
Each a little bit longer than the last, remember?
Yeah.
And you can manipulate them.
Oh.
You can change their lengths, their starting positions, and just watch them swing and interact.
Okay, I'm picturing them swinging. What's so amazing about that?
Oh, remember how they're all slightly different lengths?
Right.
That means they swing at different frequencies.
Oh.
And as they swing, they make these crazy wave patterns.
No way.
It's wild. They evolve over time.
It's like a synchronized dance.
That's one way to put it.
But how does it relate to physics?
So these wave patterns, they're a visual representation of interference.
Interference.
So when waves meet, they can either reinforce each other or cancel each other out.
And the simulation shows this.
It's like a visual demonstration of wave mechanics.
Mind-blowing.
I know, right?
It's like this one simulation covers so many concepts.
Wave mechanics, chaos theory, everything's connected.
I'm starting to see how they take something that seems dry in a textbook and make it this amazing learning experience.
Exactly. It's all about tapping into our natural curiosity.
Making us want to understand the world.
That's what it's all about.
Okay, I'm hooked. We've only explored 2 simulations, but there's so many more.
A whole treasure chest.
What are some other highlights you think our listeners should check out?
Well, there's one that explores projectile motion.
Oh.
You can launch virtual projectiles.
Like what?
Like cannonballs.
Awesome.
And you can change the angles and velocities.
So you can see how they travel?
Taking into account things like gravity and air resistance.
So cool. It's like a virtual cannonball launcher.
It is. And it helps you understand how those laws of physics govern things in flight.
That sounds fun.
Oh, it is. There's also another one that explores buoyancy and fluid dynamics.
Okay, what can you do with that?
You can experiment with different objects, shapes, densities, and see if they float.
Or sink.
Exactly, in this virtual fluid.
Oh, that's cool.
It's like the classic will it float game.
But virtual.
You can even change the density of the fluid.
Wow. I'm starting to feel like a kid again.
Me too. It brings back that wonder.
Makes learning enjoyable.
That's the goal.
Okay, I'm sold. I'm adding this website to my bookmarks,
You should.
and I encourage our listeners to do the same.
I highly recommend it.
So we've covered a lot of ground in this deep dive, from the philosophy of OER to the ways they're being used in Singapore.
It's been a journey.
But I feel like we've only scratched the surface.
Oh, definitely.
There's so much more to explore.
It's true. Learning is never ending.
That's a good point.
Always more to learn.
Okay, so we've talked about the simulations, their design, and the real-world applications.
Yeah, we've covered a lot.
But we still have one more topic to explore.
Oh, yeah.
The intersection of physics and art.
This should be good.
We're going to dive into that amazing pendulum wave effect simulation
Can't wait.
and uncover the beauty at the heart of science.
Stay tuned.
We'll be right back.
Ready to keep going.
Yeah, and before the break, we were talking about how these simulations can really make learning
Interactive.
and engaging.
Totally.
But I'm curious about the design of them.
Oh, yeah, the design is key.
Like, what makes them so effective?
Well, educational researchers have been looking into that.
Okay.
One of the big ideas is scaffolding.
Scaffolding, like the stuff they use in construction.
Exactly. Think of it like a temporary support structure.
Okay.
Helps learners build their understanding.
I like that.
So in these simulations, it can be things like clear instructions,
Whoa.
visual cues,
Yeah.
even hints and feedback as they go,
So it's like giving them the right amount of support.
without overwhelming them or doing the work for them.
Right, finding that balance.
That's where the art of simulation design comes in.
The artistry.
Yeah, finding that sweet spot between guidance and exploration.
I see.
So they can make mistakes
Learn from them.
in a safe space.
That makes sense.
It's like having a virtual mentor,
Yeah, always there to guide you.
but still encouraging you to think for yourself.
And I bet these simulations also use other design principles.
Oh, yeah, for sure. Like what?
Gamification,
Oh, it's
personalization.
gamification. So you're telling me learning physics can be like playing a game?
Kind of, by adding game-like elements.
Challenges.
Rewards.
Oh.
They make it more engaging and fun.
Especially for younger learners.
Absolutely. It taps into that competitive spirit
I love that.
and personalization.
Yeah, what's that about?
Well, some simulations let learners choose their own avatars,
Oh, cool.
set their own goals,
Hmm.
even adjust the difficulty.
So it's really tailored to them
It's like a custom-designed physics course.
at your fingertips.
Amazing, right?
And I bet as technology gets even better,
Oh, yeah.
we'll see even more personalized learning.
Totally. The future is exciting.
Okay, I'm sold on these simulations being incredible learning tools.
They are.
But let's talk about accessibility.
Oh, yeah, that's a big one. Just because these resources are free online.
Doesn't mean everyone can access them.
Right.
Not everyone has good internet.
Or a device that can run the simulations.
Definitely barriers there.
So even though the resources are free,
There are still challenges.
that can limit access.
And that's something educators and policymakers need to consider.
As we move towards more digital learning,
Big time.
are there any initiatives in Singapore addressing this?
Oh, for sure. Singapore is really proactive about digital inclusion.
What are they doing?
They have programs that subsidize internet access
Okay,
and provide devices to families who need them.
that's fantastic.
And training for teachers and parents on how to use these resources effectively.
So they're really trying to make it accessible for everyone.
As much as possible.
It's encouraging to see that.
It is.
And it's not just about access, right?
Right.
It's also about making sure the content is relevant
Culturally relevant.
and has language support.
These simulations are translated into multiple languages. They adapt them to local contexts and examples.
That makes sense.
Learning is always better when it's familiar.
Right, connected to your own life.
Exactly.
Okay, I'm really impressed with Singapore's approach to all this.
Me too.
But I'm thinking about our listener who might be wondering,
Yeah.
how does any of this help me in my daily life?
That's a great question.
What would you say to them?
I'd say physics is everywhere.
Really?
It's not just in textbooks.
Man.
It governs how things move, how energy works, how the universe works.
So even if we don't realize it,
We're interacting with physics every single day.
Wow, I never thought of it like that.
And understanding it can help us make better decisions.
Really?
Solve problems better, appreciate the world around us.
Can you give me some examples?
Sure. Think about walking.
Walking.
Yeah. Every step you take uses forces, motion, balance.
I never thought about it like that.
Understanding that can help you improve your posture.
Avoid injuries.
Even become a better runner.
So next time I'm out for a jog...
Think about physics.
I will.
And what about cooking?
Cooking?
Yeah. Why do some foods cook faster than others?
That's a good question.
Why do certain ingredients react the way they do?
I usually just follow the recipe.
But there's so much physics happening there. Heat transfer, thermodynamics, chemical reactions.
It's all happening on the stovetop.
It is.
Okay, I'm starting to see the connection.
It's not about becoming a physicist.
It's about understanding the world around us.
How things work.
Exactly.
And these simulations can help us do that.
They're like a gateway to scientific literacy.
I love that. And in a world full of technology...
Scientific literacy is so important.
More than ever.
So even if you don't go into a science field...
These simulations can still be super valuable.
For everyone.
It's about being an informed citizen, a critical thinker.
I'm convinced I'm adding explore more physics simulations to my list.
You should. It's a fun journey.
Okay, we've covered the design of these simulations and their real-world applications.
A lot of good stuff.
But we still need to talk about physics and art.
Can't wait for that.
Let's delve into that amazing pendulum wave effect.
It's a good one.
And uncover that beauty and wonder at the heart of science.
Stay with us.
And we're back. I'm ready to hear more about this amazing pendulum wave effect.
You and me both.
You really hyped this one up.
Well, it's truly one of those things you have to see to appreciate.
Fair enough. But for our listeners who can't see it, can you try to describe it?
I'll do my best.
Okay, so what exactly is the pendulum wave effect?
Okay, so picture a line of pendulums, all hanging from a bar.
Got it.
But each one is just a tiny bit longer than the one next to it.
Okay.
And now they all start swinging at the same time.
Right.
At first, they're all synchronized, moving back and forth together.
Like a perfectly choreographed dance?
Yeah, but then because of that tiny difference in length,
oh,
each pendulum swings at a slightly different speed.
I see where this is going.
They drift in and out of sync with each other.
Creating a wave.
Exactly. These incredible wave patterns.
It's like a visual symphony.
It really is. And that's what this simulation lets you see.
You can play with the number of pendulums.
Their lengths.
Oh, wow. So you can create your own pattern.
Exactly. And what's really cool is that you start to see how even tiny changes,
like at the beginning,
can lead to huge differences in the pattern.
That's chaos theory, right?
Bingo! Small variations leading to big changes.
It's amazing how something so simple
can be so complex.
And this one simulation covers so much.
Wave mechanics, chaos theory, it's all connected.
And you said there's an artistic element, too.
Oh, yeah. These patterns are seriously mesmerizing.
So it's science and art coming together.
It really is, showing us that physics is more than just equations.
It's about the beauty of nature.
You got it.
Okay, I get why you were so excited about this one.
It's pretty cool, right?
Definitely. So as we wrap up this deep dive...
It's gone by so fast.
The key takeaway you want our listeners to remember.
I think the big thing is that learning doesn't have to be boring.
Right. Stuck in a textbook.
It can be interactive, exciting, even beautiful.
These simulations show us that
technology can make learning so much more engaging.
And they remind us that physics isn't just a subject in school.
It's the language of the universe.
All around us.
So by exploring these simulations,
we can learn that language.
And see the world in a new way.
I love that. So for our listeners out there, if you want to learn more about physics,
or just have some fun,
check out the Open Educational Resources /Open Source Physics at Singapore website.
You won't regret it.
And who knows, maybe you'll even create your own simulation someday.
That would be awesome.
Thanks so much for taking us on this deep dive.
It's been a blast.
I've learned so much, and I hope our listeners have too.
Me too.
So until next time, keep exploring and keep learning.
And never lose that curiosity.
We'll see you all on the next deep dive.